right, thank you everyone for joining our Future Flight Friday session on immersive technology. I'm Ash Easton and I lead Immerse UK, which is the UK's network for immersive technology professionals. Our organization sits within the digital and creative team of the KTN, for those who don't know, and we're very delighted to join forces today with the KTN transport team to deliver this webinar. During this session, we will be exploring how VR and AR are uniquely placed to visualize and develop the future of air travel. So this technology is still relatively new, but has a wide range of potential. And we want to use this session to not only highlight case studies, but also to provoke discussion about what could be possible. So I'm delighted today to be joined by three excellent speakers. We have Jessie Mubery from Mubery Consulting, Wanda Manoth-Nimola from KLM, and Dr. Chang Mu from Extend Robotics. So we're going to have three presentations back to back, and then a 30-minute discussion and Q&A with the speakers. So I highly encourage all of you to get involved and actively send in your questions throughout the presentations, and then we'll get to them at the end. So without further ado, I would like to introduce our first speaker. So our first speaker is Jessie Mubery, who's the director of Mubery Consulting, a consulting firm for scaling emerging technology. So most recently, she also served as the head of deployment at Airbus's innovation unit in Silicon Valley. She also served as a technologist at the Peace Innovation Lab at Stanford University, and she's currently designing an AI software safety class with the University of Southern California. She served on multiple boards of directors, including People's Light, Uplift Aeronautics, and the Global UTM Association, as well as advisory boards such as NASA's Urban Air Mobility Initiative and We Robotics. So thank you for joining us, Jessie. You can take it away.
Thank you, Asha, for that wonderful introduction and for having me here today. Today, I'm going to talk a little bit at a high level, the ecosystem and where some of the business opportunities lie. So today, there are over 100 companies actively building urban air mobility vehicles with over $1 billion of capital deployed. There are manufacturers and regulators and air traffic controllers, tech providers, and entrepreneurs all working together to make the future of flight a reality. It's a really exciting time to be in the industry, but the truth is we need more entrepreneurs, we need more thinkers to bring about this kind of future. So in this talk, I'm going to talk about the ecosystem and then what those business opportunities look like. So what's really unique about this time is sort of the convergence of lots of different factors. So there's new airframes entering the sky, there are new missions being flown, there's going to be new densities of aircraft flown in our skies, and there's going to be new automation capabilities. And so when we talk about new airframes, I've used an example from Airbus here on the right-hand side. So the first vehicle you see at the top is a high-altitude pseudo-satellite aircraft. So this flies above commercial traffic and can provide connectivity to remote areas. It can also provide remote sensing technology. And this vehicle can stay in the sky for weeks at a time, which is really incredible. Powered via solar power. It's a really unique airframe with really different types of missions that can be flown and opens up a lot of potential. Now, the two vehicles sort of in the middle there are sort of what's traditionally called an urban air mobility vehicle. The US is now calling it an advanced aerial AAM mobility. But in short, these are electric vehicles with distributed propulsion that fly short length trips and have high turnover rates. So you could think of these vehicles as being something you might be able to order on your smartphone and fly a 20-kilometer trip in about 15 minutes. And so these vehicles are envisioned to change the way that we move around cities and we move between cities and urban hubs. And then, of course, at the bottom is an example of a drone. Drones are changing a lot of facets of life, from how we receive packages to how anti-poaching activities are managed, to firefighting, providing firefighters with an eye in the sky and increased visibility of what's going on in the ground. And so, you know, these new airframes are also sort of paving the path for places that aircraft have never flown before. And so, an urban air mobility vehicle might take off on a roof and fly to a traditional airport, or they might take off from a park and act as an emergency ambulance vehicle to deliver to a hospital. And it just adds a whole new level of complexity that we're going to need smart thinkers and technology to solve. And of course, because of all these different use cases, there's going to be lots of different densities of aircraft interacting in the airspace. And there's going to be need for decongestion, as well as making sure that they're flying in an orderly, safe fashion. And of course, new automation capabilities. A lot of these aircraft are envisioned to be flown entirely autonomously at some point. Maybe they don't start off there, but a lot of the designers are thinking about how do we get steps to be built to build them fully autonomously, which is really exciting. But also, once again, we're going to need new technology and new entrants to help us solve some of these problems. And so what's interesting is these new technologies are being introduced into a very sort of rigid ecosystem. The aviation field has been around for a while, about 100 years, and they have developed rules and regulations to keep us remarkably safe. I mean, you're much safer flying on an aircraft than you are driving your car down the street. But these rules and regulations are quite stringent. The existing infrastructure is quite expensive to build and maintain. And the connectivity that exists today is okay, but could be improved a lot to unlock some of these capabilities of these aircraft that are being designed for the next stage of aviation. So I'd like you to close your eyes for a moment. I'd like you to imagine that you are in a city. Think of some of those aircraft that I just talked about: urban air mobility vehicles, high altitude drones, low altitude drones. And I want you to kind of picture what the sky might look like. There is a myriad of new challenges for these aircraft, but think of how interesting and how useful it would be if, for example, you were in a park and somebody next to you had a medical emergency, and you were able to go into your phone. In the US, we would dial 911. In the UK, I'm not sure what you would dial. And within 10 minutes, a vehicle would fly over, land, and pick up the person that was having a medical emergency and take them within 10 minutes to the nearest hospital, completely flying over the congestion and delivering that person safely and efficiently to the care of a doctor. That's the kind of thing that this technology could do if we put all the pieces together in the right way. Please open your eyes. And so those of you here today are thinkers, you're idea people. Just by nature of being here today, you're working to solve problems. And so at a high level, I wanted to talk to you about some cutting edge technologies and how they could be applied to this field. Excuse me. So for those working on AR and VR, one of the big challenges is the passenger experience. How will the vehicle communicate to you, and how will you communicate to the vehicle? So let's say the vehicle needs to be rerouted, and it's now not possible to reach your previous destination because, for example, there was an emergency event and the air needed to be cleared above a stadium, for example. The vehicle needs to communicate why this is happening, that it's still a safe situation, but that the trip is going to be changed. How could you do that with a headset, or how could you do that in an immersive experience? Another example is the passenger has an emergency and needs to communicate to the vehicle. What do those human interfaces look like? And how do you provide enough information that the vehicle can make safe decisions about the routing and about how it's going to deal with this emergency that has arisen? A second example of how to use AR and VR is, how are we going to train our operators to fly these vehicles? If they're not going to have passengers or other humans assisting inside the vehicle, there might need to be a training regimen for those that might need to take over these vehicles and fly them remotely. So designing a training program for operators could also be another way to apply your experience in AR and VR. Now, in terms of and background in AI and ML, this is really key just because of the sheer amount of data and learning. As you know, autonomous systems require an intense amount of data to process, to check against, and to continue to update themselves. And so this is going to be true for routing and optimization. So I gave the example of if you are flying your vehicle and another emergency vehicle needs to take priority, then there needs to be a lot of analysis in the background of rerouting, making sure there isn't a domino effect in the airspace where you're flying one way, the other vehicle is flying, and you have to avoid each other, thereby causing another series of avoidance maneuvers for other aircraft in the airspace. And then finally, around 5G and satellite connectivity. In order to do a lot of these maneuvers, we have to be able to constantly communicate with other aircraft, with air traffic controllers, and with surfaces that provide safety and risk management. And so this technology is also going to be really important for identifying where the vehicle is, what its intentions are, and ensuring that it is flying safely. So this next era of aviation is coming quickly, but it needs experts and entrepreneurs to be involved and to apply their learnings in some of this cutting edge technology. So I would ask you today, what problems could you solve in this next area of aviation? Thank you.
That was excellent. Thank you, Jessie, for setting the scene for us like that. That was fantastic. Next up, we have Wanda Meneth-Niemöller, and just do a little quick introduction. Wanda is the current commercial development manager at KLM Training, Engineering, and Maintenance. She joined KLM over 28 years ago, and having done several functions in the passenger business, the latest as manager intercontinental flights and planning. She joined KLM Engineering and Maintenance a little over 5 years ago. So since then, she's done many things, but amongst them, she has gone on to found Nuvion, which is a joint venture between AFI, KLM Engineering and Maintenance, and the Netherlands Aerospace Center. And it involves the use of the Microsoft HoloLens. So I'm gonna pass this on to Wanda. Go over.
Asha, thank you very much for the introduction. Well, as said before, I've been basically for the last 3-4 years fully involved with innovation. And today what I want to discuss with you about is augmented reality, basically in maintenance and repair organizations. And is it a gimmick or a game changer in the industry? And hopefully by the end, you will see that we have proven and are very convinced that it's a game changer in the industry. First of all, why do we innovate? Engineering and maintenance is originally a very old-fashioned paper community, which is taking quite a long time to change. But the whole world around us is changing, especially the young people who are coming into the aviation world. If they have the choice to become a pilot or to become an engineer, usually the pilot is a more sexy job instead of becoming an engineer. So why do we innovate? Well, first of all, you need to be competitive. If you are ahead of your competitors, you attract the new young people themselves. You need to be social attractive for them. You need to be up to speed and not this old-fashioned company. Of course, you want to make it operational more efficient. A lot of times, of course, airplanes, they need to fly. And instead of having them on the ground for training purposes, you want to use different technologies because, well, you earn your money if they are flying. So with that, you have also strategic efficiency towards your competitors. What is the new future of jobs? What we see changing is that we have like a large growing middle class where the students can go to a higher education. So people are at school at a longer period of time. So the rise of the middle class is something that we have to step into as well, because the engineers of the future, they are definitely from a middle class, and they're not anymore from a lower class where they only work with the dirt jobs. It's a large growth of urbanization, and how do we attract those people who now have the choice also to go into more sexier jobs, different jobs. And one of the things to attract them in early age is that we introduce technologies and innovations. And with that, we are more flexible, but also more attractive as an organization. Well, what did we do? What did we do in innovations, and in this case, in augmented reality? In 2016, together with the Dutch Aerospace Institute, we decided to see if augmented reality was mature enough to be introduced in maintenance and repair organizations. And we decided to give a first trial into the training organization. What you see here is basically we created a platform which is a closed environment. So we are not depending on heavy systems. So we have a closed environment in which a group of students can connect, and they all basically see the same 3D object in the reality. So the big difference, because we already started off with virtual reality, everybody is closed in, but especially with certain kinds of training, you want the engineers or the students to interact, because basically in real life, working on an aircraft, they also have to discuss with each other, what's the situation, what are we facing, and then basically solve the solution. In the early stage, we decided to take basically 3 system parts of the aircraft, which are very hard to explain in a classroom, and also very hard to show practical. Here in the middle, you see the air conditioning system, which is basically built in on the bottom side of the aircraft, and you don't really see the system. What we did is we built scenarios in which you can basically walk through an X-rated air conditioning system. You can change the altitude of the aircraft, temperatures, and with that, the students had to solve scenarios. And by solving scenarios, working together with a 3D model, we found out that they had a very high understanding, because basically seeing is believing, but doing and actually working on it, that's where they really start learning. One of the other systems we built, which is of course very hard to show, is the fuel systems. Here inside the wings, which you can see on the picture, you can see the entire fuel system, all the different valves, the pipes, how they are connected, how it is working. That's something you will never ever be able to explain in a real classroom situation. We built in, again, scenarios in which they have to solve the problem all together. And the third system we built was equipment cooling. As you can see on the picture, you can't hear it because in this scenario, there was like a fire in the cargo hold. So they see smoke, they hear the alarms in the cockpit. And then again, together, it's like being in the real situation, they had to solve the problem. After doing basically 2 simultaneous groups, one group was doing the old-fashioned way and the other group was doing the training with the HoloLens. all of the students with the HoloLens, they felt basically 83% felt completely competent to start, even without doing the practical on the aircraft, to start and performing the work on the aircraft, which is a big difference according to the normal old training solutions. So then we decided this is not a gimmick, it's really a game changer. So on the Paris Air Show in 2018, we decided, of actually 2019, we decided to incorporate Nuvion. And basically, as of then, we said, okay, it's not just a proof of concept, it's a product. So we looked in where do we have real business cases, because entering augmented reality, for most people, they think it's a gimmick, it's very expensive. So we had to prove that besides it is working, we also had to prove that you can save money, or what are the advantages, so you get like return on investments. Well, one of the difficult things, for instance, is doing practical tasks on an aircraft. As mentioned before, we rather have them flying than standing on the ground. And also when you do practical training, you do not have always all capabilities within your fleet. For instance, what you see here is we built an additional engine training where you can study for an extra engine, and that was actually an engine we do not have in the fleet. So to do the practical, we were normally depending on aircrafts from another airline, which also had the habitat of not being in Amsterdam. So we always had to fly to another destination. Well, for a one-day training, you lose 16 students for at least 3 days with the costs of a hotel. So we had very quickly built, our business case. So we built basically an engine, basically a little bit of a box where we have all our tools in, and the cockpit, because this is the whole system. The explanation is how the systems are working, the engine and the cockpit, because that's how the whole situation. We got the approval from EASA, which is a worldwide organization, to do the full practical training in the HoloLens instead of using the aircraft, which is, especially in aviation, quite revolutionary. Next, I will show you a very short video so you can have an impression of how this actual class felt like. What you see is basically the 3 students. They have boxes around them, so you know that you are all connected and everything what you see is aligned. They had to do basically all practical tasks like an engine run up, which you normally have to do on an aircraft. They have to identify the different spots. It's the connection of 2, actually, in this case, 2 different groups working beside each other. So you can even run simultaneous different student groups, because we found that with a smaller group, it's usually easier to work together, and also the trainer can be part as an assessor. And with the trainer being the assessor, they could also right away do all the tasks and sign off for the practical to get the EASA approval. From the training part, which is a very steady environment, we are now working on business cases to introduce augmented reality into the operations. We are working together with artificial intelligence, basically for damage assessment on the aircraft. You scan the aircraft when there is, for instance, a damage. You interconnect through augmented reality and have basically a very quick solution to solve the problem and make a decision whether you have to cancel the flight, basically repair the aircraft, or that it's safe to fly. So our current processes we're now working on is really introduce it into the whole operations. Remote access is one of the other things we are currently working on. So definitely we know, and we have, I think, proven already that it's not in the future anymore, but it is today, and it's getting more and more being part of the maintenance, repair, and organizations to be for here and the future. I want to thank you for your attention.
That was great. Thank you so much, Vonda. Fantastic. All right, so we're going to move on to our third and final speaker. I'd like to introduce Dr. Chang Liu, who's the CEO and Chief Designer of Extend Robotics. Chang is an entrepreneur who has worked with intelligent robotic development projects in academia and startups. Previously, he was a research associate in Imperial College London and the University of Southampton on autonomous aerial robotic navigation in the offshore industry, as well as the head of robotics in Econova. So Chang, over to you.
Hey, hello everyone. My name is Chang. I'm the founder and CEO of Extend Robotics. Thank you so much, Asha, for the introduction. So in Extend Robotics, we built a robotic arm that is affordable but capable of remote operations from anywhere in the world using cloud-based teleoperation software. So our technical founders are postdoc and PhDs from Imperial College and our commercial leadership from Huawei. Yeah, so really it starts from this background of robotic market that the new trend of digitization and automation is transforming almost all industries, and new technologies are approaching the slope of enlightenment. At the same time, we have this new challenges of labor shortage and really the pandemics. That's really driving the new technology adoption for every industry. So all of these contribute to the exponential growth of service robots industry. And so we're expecting a 40 billion market revenue in 2023. So actually, in every 5 service robots supplier is a startup. So yeah, of course, I cannot avoid talking about COVID. 65% UK office officers believe working remotely will become more common even after pandemic. And in many traditional industries are showing the need for remote working even for physical tasks. So this is probably the worst time for a human, but I guess it's the best time for robotics. The fact is that still over 50% of the jobs today still cannot be easily automated, even by today's robots, due to the limitation of the dexterity and their intelligence. And at the same time, they are very low scalability and high cost. At the same time, there's many industries that have a huge need to avoid human labor presence in their work to get the work done safer, faster, and cheaper. So how can the new robots help with this? Since 1950s, teleoperation robot and autonomous robot are kind of complementary between the cost and dexterity. But what people really need is a robotic system that is both affordable, but at the same time provide flexible dexterity people need to complete their job reliably. So this is really what we do. So in our solution is that we're building the next generation teleoperation robot, which is an affordable VR-controlled robotic arm that is accessible from anywhere through the cloud. So normally it works as a physical avatar of the user to do manipulation tasks remotely. That's why we call it the avatar twin. Yeah, our avatar twin is a robotic manipulator to be integrated into existing robotic solutions or any like drone applications. The drone, the core of the avatar twin is that it provides human-like dexterity to do complex operations. It gives a seamless human interface to allow anyone to control it seamlessly. It achieves superior scalability with connectivities and our autonomous roadmap, and at the same time we can still package everything in a very low price in the market. So our robot toolkit is a hardware that is affordable robotic arm, providing human-like dexterity and perception. It is uniquely optimized for teleoperation with integrated 3D perception and computing and high power to mass ratio to lift heavy objects, and safe, compliant, dedicated operation with brushless motors. So our advanced mechanic assistance system, AMAS, is a special VR game that is connected with a physical robot. So it provides immersive 3D perception and an intuitive gesture control with consumer VR equipment. With our patent pending point cloud streaming algorithm, we have achieved 6 times latency reduction and 50 times bandwidth reduction compared to a standard method used by most robotic companies. So this technology takes the remote human-robot interface to the next level with faster and more precise operations, easy to use by non-experts, low cost with consumer VR equipment, and comfortable operation without any motion sickness. Yeah, so if anyone interested in more details, you can come to our YouTube channel and Extend Robotics for our product walkthrough. I don't want to waste time here, but yeah, welcome to have a checkout. Yeah, so how are these type of robot arm could be useful for aerospace? Well, yeah, so we can for example attach the robot arm on a crawling robot that will actually allow effortless maintenance on aircraft, so people don't have to climb up to reach the complex locations. Adding like a lightweight robot arm onto UAV or drones enables aerial manipulation for risky operations at height. Robot arm could also be added to a drone ground station for logistic handling or maintenance of the drone itself. For example, swapping the batteries or fixing broken parts. So we can have a full humanless drone station that's improved the efficiency. So yeah, so without any human presence. Yeah, so I'm really keen to discuss with further details with anyone who's interested. So please follow up if you're interested. Thank you so much.
Wow. I have to say that my mind is actually completely blown by this. I mean, we've had VR controlled robotic arms that can be attached to drones, multi-user AR maintenance, the future of, drone travel and the potential for using VR for drone operations. It seems like a pretty exciting future, but I know it's very, very early for all of this, really. We have a couple of questions here, and I have a bunch of my own, actually. The first one I want to ask is, and this is for all of you, really, because so we have Wanda's multi-user AR, Chang, you have teleoperation robots, and the AMS VR software. And Jessie, you brought up a couple of times connectivity issues with having to, at a high level, if you're going to be having lots of drones or all of these aircrafts working at the same time. What are all of your feelings about connectivity issues and making all of this stuff work? Oh, you're muted, Jessie.
Got it. Thank you. Yeah, so connectivity is a really big challenge in the industry. So your typical LTE providers are really focused on providing service to cell phones, which are generally like a bit over a meter off the ground. And so that's what a lot of the optimization is for today. So if we need connectivity for aircraft that are flying much higher off the ground and are moving generally much quicker than your average mobile phone is, then you have different triangulation issues that need to be solved. And as 5G is rolling out around the world right now, there's a lot of conversations about whether it will be reliable enough at the right altitudes, at the right speed to support aircraft. And so if not LTE, then what other technologies could we use for connectivity? And it's just a really big issue in an industry that is going to be very dependent upon connectivity in the future if it's going to be successful.
And Wanda, with your multi-user AR maintenance operations, what do you think about that?
Well, I think we are a little bit more in a lucky situation if it comes down to location, because usually locations for us are airports or hangars or usually facilities which are well connected, though sometimes on, more remote airports, it might be a little bit more difficult. I think with the connectivity, I think a bigger issue to solve would be security. How do you secure your systems? How do you connect it to your systems? Because if you use multiple devices, it's always a challenge, because everything what you bring from outside to the inside might be a security breach, and especially in aviation, that's very tricky. So connectivity, I think that's something which we will be able to solve. It's more how do you basically integrate all the different devices security-wise within your systems. And I can imagine that would be the same challenge for Chang as well as Jessie. How do you secure it that everybody feels safe enough to use it?
Yeah, that is a widespread issue for adoption in with immersive technology. I mean, in all industries, it's something I hear about all the time. Chang, do you have any thoughts about that? Like, what are the security concerns for a tele-operated robot?
Yeah, so security is definitely one of the big issue for future massive usage of this teleoperation system, because you're essentially enabling someone to controlling the robots remotely, and at the same time you are allowing your data to stream through the network. So if, for example, you're helping someone, the robot is helping someone at home for home service, then you don't want your data to be streamed somewhere you don't trust. But in addition to that, I think the bandwidth and latency is also a very big issue for a large amount of IoT devices, where you're talking about streaming like a gigabytes data across the network, each robot, and then how do you handle that amount of data in the network? And so these are quite challenging things which we are facing. Yeah.
I have a question here specifically for Wanda. Someone is asking, are the AR exercises that you're doing leading to any feedback to the airframe manufacturers, like better designs for maintenance, for example?
Well, currently what we are doing with augmented reality is in training, and definitely we are sharing what we are doing with the airframe manufacturers, and they are very interested to learn what we are doing and how we are doing things, because the airframe manufacturers also have the same mutual interests to perform high standard training in which you have the most efficient and qualified students. Definitely, I expect in the future that you also can get better designs for maintenance. actually that's something which we are already currently doing without the innovations, is whenever airline operators or maintenance repair organizations are working on the aircrafts and they see things which think could lead to a better solution, we are always in contact with the OEMs and to discuss either solutions to a problem or to have a new repair solutions. And well, when discussed, it is basically always, if agreed by the OEM, it is embedded in the system. And then, of course, again, other airframe manufacturers or maintenance repair organizations can use the new approved repair. So basically, that's a system which is already currently working. And definitely the innovations, especially when you use it more and more, you can record it and share it. It will probably even go faster.
And I guess, you know, from a KLM perspective, I mean, you're using obviously VR and AR with in traditional aviation, but what about for the future of maybe UAMs and drones? Is that on KLM's radar? I imagine it might be. Do you know?
Yes, definitely. We are working, of course, on drones to introduce drones within our repair organizations. One of the biggest hurdles I think every organization is working is facing is especially working on an airline field or an airport. Drones is one of the biggest issues, and nowhere worldwide it is approved yet. So that's one of the things, is how do you introduce it? How do you get your authorities on board? Because especially drones within a hangar, you can use it, but even within a hangar, you have restrictions, approvals. So currently we are using it for damage assessment on top of the aircraft with AI. You can do damage assessment quite quickly. They have a very good software currently built for it. And yes, it will become more and more, but every step in innovations, what you do, you have to take along your authorities, because if they are not on board, you won't get an approval. So if you want to use them in the future for basically repairs, because, well, we have now engineers who have studied for years and they need to sign off on an aircraft. And if your authorities are not convinced that the machine can do the work, you won't get an approval. So that's one of the biggest challenges you always have to face and take them on board from the beginning. If not, you will definitely have a problem.
Something I thought about as you were all speaking, and especially Jessie, when you were talking about the future of airspace and potentially using VR, AR to for drone operators or to visualize the airspace potentially. There's a game actually out there called Microsoft Flight Simulator. Have any of you heard of it or played it by any chance? No. It's a really cool game actually, and they basically bring in like geospatial data. So it actually, I think it's actually in real time data of like airspace, so you can fly in all kinds of different aircrafts. And there's a VR version that's in beta, and I tried to get it, but you need a headset that I don't have. And they're doing an HTC one soon, which I want to try and get my hands on. But I've not, you know, that's the first kind of thing like that I've seen or heard of. I'm wondering if what they're trying to do with that could then somehow be applicable to what you're imagining, Jessie, with like an interface to, you know, control air traffic.
Yeah, I think I've played much earlier versions of that game without the AR and the VR, but I think doing it with a headset would be a wonderful experience. I think there is a huge opportunity there, because a lot of this, one of the challenges ensuring that humans are in the loop and still maintain control. Even as we roll out this technology, that a human can stop it at any point once they identify something wrong. And so having that perspective of what the machine is actually seeing in front of them, what's their operational situation around them, I think is really important. So I think it almost creates a little bit more understanding between the manager and the machine. And so, yeah, I think that's a really neat idea.
Chang, do you have any thoughts about that? I mean, you have created your own VR software with Amos. It's kind of similar.
Yeah. I think our software, our VAMAS could be used in drones also with some modifications. The concept is the same. I think the key value. I agree with Jessie that is all about like situational awareness and the transparency of this automation or robots or like a system to human operators. We can. I mean, human can always stop the robot from doing stuff, but really, like, how do you identify what is doing wrong, and how do you maintain control? Without knowing the detail of what the robot is doing or what the drone is doing. So this is really giving human operator a very intuitive way to understand what the robot or drone is doing. And at any time, they can take in control. They always stay in the loop. They know what's going on in the robot or drone. So that's really an important safety feature to be included in the future industry development.
Yeah. And I mean, Wanda, you spoke about like the jobs of the future and where things are going and what's the future workforce going to look like and what do they want in their jobs. Like this, I mean, this feels pretty important. Like this is like a new interface. These are like jobs that don't necessarily even exist yet. How do we prepare for that?
I mean, hopefully in the future we could have a dedicated job to have someone supervising the robot. So really, like this interface in terms of the job problem, like a massive unemployment. If we don't have a good interface from human to robot, then if the robot becomes completely automated, and you don't necessarily need any human anymore, and then it's very important to keep the operator or the human operators in the loop during this involvement. So in short term, it could be used as an educational tool or safety tool, and then in long term, people continuously involve together with this autonomous robot revolution. So we don't get left behind. We keep developing with the robots together, and we're part of the story. We grow together, and that would be a fantastic future, I would say.
That's great. Wanda?
No, I definitely see all the new developments more as an add-on to the present workforce, to make their work easier, to help them make better and better decisions. So the good thing is take them on board as early as possible and involve them in all the developments, because when they are involved, they will carry it through your operations and they will just use it and improve even better. I don't see it as a threat to the workforce. It's just to help them do their jobs better.
Nice. I had another question here about, because I know that Jessie, you've written actually a paper on this. So my question is, could there be a role for VR and AR in public acceptance of this new future flight technology?
Yeah, public acceptance is a big challenge, and a lot of people are talking about it, but there's not a ton of work being done on that front right now. And so when I was working with the NASA advisory group on UAM, and then subsequently my work with Airbus's innovation hub in Silicon Valley, we identified that public acceptance was something that there needs to be more research on. And so I conducted a study where we quizzed people from around the world about what were their feelings on urban air mobility. Would they be willing to fly in a vehicle like this? What did they think some of the blockers would be from their, in their opinion? And what came back was that people didn't necessarily understand the technology, and things that they don't understand, there's less likelihood to be adopted. So we had about a 50% adoption rate of this technology just from the survey, because there was a lack of understanding. And so I think that the AR and VR can be used to educate and train people about this technology, the high quality of engineering that goes into it, the benefits of it. What does it mean to fly in a vehicle? Because I think 10 years ago, maybe 99% of the global population would say, I am never getting in an autonomous car ever. And now we have vehicles coming out that have a lot of automated functionality, and some manufacturers are talking about going to full levels of autonomy. And then, so I would imagine that this public education and bringing them along in the process will have big implications for whether the public decides that this is something they want operating in their communities, or whether this is something that they are not going to accept. They want to have a pilot flying their vehicles. So I think there's a big opportunity for AR and VR in the education space there.
That's exciting for me to hear, obviously. I mean, so I think did we have one more question here? I guess my next question is really for you guys, because we have this industrial strategy challenge that's providing $125 million to aerospace and other manufacturers to research and engineer new technologies and infrastructure. So this is like a big government program that's going to go over years. And I guess, I mean, how could you see like a potential case study or use, I guess, for immersive technology in this? Do you feel like there could be something relevant that we're talking about today that could be piloted, for example?
I'll go first. Absolutely. I think there's a ton of things that could be done in this space, whether it's on training, whether it's on education, whether it's on like giving human managers oversights of automated and autonomous systems. There's a ton to be done there. And I think it's a fantastic program from the UK government. And I think it's going to move the whole industry forward and encourage businesses to invest in the UK and the future of aviation there. So I'm quite happy that the UK government has put this together.
Wanda, any thoughts?
Yeah, I fully agree with what Jessie said. It's definitely good, and I think immersive technologies can really add on to this. It will be, of course, keeping in consideration the whole environmental issues, how you can diminish this. So yeah, definitely.
And Chang, any final thoughts?
Yeah, so I think for immersive technology for this industries, manufacturers and robotics, it's really in short, it is a human-machine interface that we that is the value for this immersive technology into this industry. I think at the moment the community from immersive and the manufacturers are quite separate, like at least from the technical development point of view. So I can see there is a huge need to huge demand to kind of combine the two communities developing together. And I think the investment and this potential grants and could bring this the two communities together and building the next generation human machine interface. Yeah.
Great. Well, thank you all so much for your time. That was really, I think, a really interesting discussion and conversation. Thank you for everyone who joined us today. I think we'd all be happy for you to follow up with any of the four of us. Reach out via LinkedIn, or I think everyone posted their email at some point during their presentation. So please reach out if you have any further questions. And I just also want to flag to save the date for the next webinar in the series, which is going to be on November 13th at 1 p.m. on future flight safety case consultation. And I think I'm just trying to click through. And then next month, there's also zero emission infrastructure webinar on November 27th at noon. And to find out more about the Future Flight Challenge, you can connect with the network and find collaborators and contact any of us at the KTN if you have any questions about finding collaborators or need help with that. And just the final slide. Thank you so much, guys. Appreciate your time.